go. First announcements. Today's lesson is the last lesson that we do in Chapter 3. 3.5 we will pick up after Chapter 4. Closure includes division, and we don't pick up division until Chapter 4. So we suggested, Ms. Dorier and I suggested to the county to do that after you've learned that operation. It would make more sense, so that's when you will see it. Also, you know that tomorrow's survey is due, survey number 4. It's due your class period, not at midnight or anything like that. So please, please make sure you get that in. Your homework tonight, which I'm going to start with lessons in a sec, are from the textbook, not the skills practice, but from the textbook your homework is. So that'll be what you want to take out right now. We'll be filling in some notes in the textbook. Your homework is on page 269, number 8, and then also page 276. So you can see that I made a new assignment board right here so that you can see the week coming up. Your test is Wednesday. Extra help is today after school. Your graphing quiz is Thursday, and the last retake opportunity, as you know, is on 10/10. So that's things that are coming up. Okay, here we go. Today we're looking at some key characteristics of polynomial functions. You already know most of this, and then as I get down to the extrema, we're going to talk about it with my chart so that it clicks. So it's not just like a formula, you understand what it is. But first off, it's talking about absolute max and absolute min. What is an absolute max or min? Good. The highest point on the whole graph or the lowest point on the whole graph. Then it talks about the word extrema. That's the new word of the day. The extrema includes your extreme points, your turning points, your high points, your low points, etc. So they're all of your absolute and relative maxes and mins. Would I use that word on the test? Yes, I would. So just make sure you're familiar with it. On the study guide, I didn't go back and look and see which problem it is, but it'll ask you to list the possible number of extrema for, and then I give you a question. So somebody, while I'm chatting, look and see what problem number that is, and we'll talk about that last. Once we are looking at extrema, it has to do with the degree of a problem. So if my degree is n, and it's a 5th degree equation, the rule says there's going to be n minus 1. The maximum number of extremas would be n minus 1. So 5 minus 1 means there would be 4. If it was a 28th degree equation, then the most amount of extremas would be 27, n minus 1. That's what it's talking about. Okay, so here's some visuals. This is right out of your textbook on page 265. Can somebody open the door for me, please? Thank you. Awesome. Thank you. Lovely. Thanks. So on these two graphs right here, they're both examples of a 4th degree equation. The first graph is the parent function. It is just a 4th degree equation without anything fancy. The next one is your 4th degree polynomial because it has that extra little swiggle in between. So can you see that on this first one there's 1 turning point? That's my number of extrema. Can you count on this next one? 1, 2, 3 turning points. So there's 3 extrema. If I said, tell me for my problem, like I just said, it is a 4th degree polynomial, and I want to know the possible amounts of turning points or the possible number of extrema, then you would list them out. There could be 3 or there could be 1. Okay? Next one. We're going to start at the end because if not, they're going to trick you right here, I think. So look at the very far end. So we're talking 5th degree polynomial. Could you count the number of turning points? So like mountains and valleys, how many do you count? 4. Very good. So that would be how many number of extrema? 4. Okay, look at the next one. How many do you count? 2? Okay, now, what do you think of the next one? 0. I heard a whisper 0. It is 0. Think about this one. It's kind of like a line. Does a line have a max or min? It goes to the right and left, up, down, forever on your nice diagonal line. That's what this is related to. It does not have a valley, nor does it have a hill. There's none of that happening there. It just swiggles in between. So the rule will tell you n minus 1 is what we're using. So this was a 5th degree. 5 minus 1 is 4. It counts down in increments of, what do you think? It counts by increments of 2. Don't go below 0. Okay? So that was another example. So now let's look at this guy. 6th degree polynomial. So I can start from the left side because I don't trick you on the evens. So how many turning points? 1. So there's 1 extrema. How many turning points? 3. 3 extremas. How many turning points? You've got it. 5 extremas. So if I told you you had a 6th degree polynomial, at most, or I'd say how many possible extremas could you list? You would go 5 or 3 or 1. I start with the most and I count down. If I have a picture, I can count them. Without a picture, I don't know if there's 5 or 3 or 1. I know the most amount there could be. I know how many possible there could be. Good? Okay. So here is by their name, just so that you know. I'm not making the chart on the test, but I want you to be familiar with the most amount of extrema that each could have. What do you know about a line? It would have to be 0. Okay, next is a quadratic. What do you think? The rule is n minus 1. 1, good. Okay, a cubic. Remember, we're talking the most amount there could be. The rule is n minus 1. 2, good. What does quartic mean again? 4. So then what is the most amount there could be? 3. Quintic means, so what is the most amount there could be? If it feels like I'm saying the same thing over and over, I am, because I wanted it to sink in. I want it to be, oh, yeah, that's pretty easy. Now, the rule at the bottom that I wrote to you, it says, what do you notice about the number of extrema and the degree of the polynomial? There's always 1 less extrema than the degree of the polynomial. N is the degree. That's why we use the n minus 1. Good? Question? Okay, so I'm hoping you will get that right on the test. Did you find it on the study guide? I knew you took it out. It's not on the first page. I think it's on the next page. Talking about the number of extrema. I'd have to zip through it. I'll look in a sec. Okay, next thought. Here's a chart. On the left side, we have the even degree power function. On the right side, we have even degree polynomial functions. Do you notice that the polynomial functions have more curves in them, so they would have more highs and more lows, whereas the power function is like the parent function. The power function is x to the, in this first one for even degree, x to the 2 or x to the 4, or x to the 6, x to the 8, nothing else after. Where this polynomial might be x to the 4 plus 3x cubed plus 7x plus 18. That's the difference. So what do you notice? I'm looking at the first big row across. Compare power to polynomial. What do you notice that they have the same? What likeness do you see? What rules stay the same? What do you think? Some of you are iffy. N behaviors. No matter what, a 4th degree is either going to look like this, both arms up, or both arms down. Always, always. Doesn't matter how much swiggles in between, the N behavior will be the same. Okay? Same kind of thing with odd behavior. Odd behavior is one arm up, one arm down, vice versa, flip the arms. So what I wrote to you down here is they do have the same end behavior. The power function only had 0 or 1 extrema. That's those turning points. Whereas the polynomial functions had more than 1 extrema. Because now all of a sudden it had more highs and lows, more valleys and more mountains. End behavior. Are you end behaviored out? It's on your test. I would expect you could do that. So this question was talking about end behavior of all even degree functions, whether it is x to the 2, 4, 6, 8, 10, x to the 100. It's still going to have the same end behavior. As x, this is for a positive one. When a is positive, I'm thinking this. As x goes to infinity, so does f of x. As x goes to negative infinity to the left, f of x goes up to infinity. And then I wrote to you what happens if it's heading down. But by now, you guys should be amazing at that, so you can get that right on the test. Question on end behavior. Okay. Now, this is your page 268, which is like your number 8 on page 269. So please take good notes on this, page 268. Okay, so first off, let me erase this for a sec for you. These have arrows, not endpoints. You've not had one of these with arrows before, so we'll talk about that in a sec. But these mean they continuously go up and down forever and ever and ever. Where does it stop? I don't know, because it's going to the sky and it's going way, way, way down there. Okay, but first, could you look at this? Look at Mrs. Stewart. And could you tell me if it is even or odd? I'm answering part B first. Even or odd? Has to be odd. Everybody agree with that? Okay. Now that I know that it's odd, even picture your line, because to the first power is odd. I need to know if a value is positive or negative. It's going to the right and it's going up. So think of your line. When you have a slope of a line that goes up and to the right, it would be positive. That's the same thing. A is positive. Question so far? Okay. Can this function be cubic? No. Good. I heard a couple solid no's. I can count 1, 2, 3, 4 points on my x-axis. There is no way a third-degree equation could have 4 x-intercepts. Would you agree? Because it has to have, can't have more than the degree of the problem. Okay, next is going to be the domain. Does this go to the right forever? See on the angle, so the arrow, even though it looks like it's going up, it's slowly going to the right. Is this going to the left forever? I need voices. Yes, good. Okay. Now, the range on this is going to be different than the range on the one you're doing for your assignment. Look at this right here. Would you agree this is going up forever? It's going down forever. Question. Okay, now before I finish this, but while I have your attention, I want you to look at the homework question. So turn your page to 269. 269. It's textbook. You guys, none of you brought your textbook? Okay, look at the picture. The domain, part D on your homework, is going to be all real numbers. But look at that picture. The range is not going to be all real numbers. How high does it go? It looks like it goes up to 2 or 2.5-ish. So the range is, and then how low does it go? Forever, so what do I call that? Negative infinity, because it's heading downward forever. So I'm not doing this one right now. I'm doing the one in your textbook, page 269, your homework problem. Look there. Do you see how it's both arms are going down forever? Not skills practice, textbook. That's why I keep saying the same thing. If not, so look at that picture. because I'm trying to help you. That was a question last hour as soon as I walked away, so I don't want you to be confused with that. Somebody was like, well, you said it was all real numbers on the other, but it was a different picture. So I'm on page 269 for a sec, not my frame, but I'm talking to you, page 269. How high does it go? You got the whole chapter, you got the whole book all at once. There's another one over there. But your job was to pick it up like when you came in that day, so the next day. So it looks like the height is at about a little less than 3, like 2.5-ish maybe, and then it's going down forever. So where am I going to? I repeat that question. Negative infinity. So you can either write negative infinity, comma, -2, or you might write -2, comma, negative infinity. It's proper to go from least to greatest, but I would take it either way. Okay? That was your range, because I wanted you to see it's different. Now look again, still in your textbook, homework question. What do you think your domain is on your homework question? Page 269. Look at your domain. All real numbers. Okay? So, back to what I'm doing up here now. Okay, so now it wants me to talk about my number of relative extrema and my absolute. So here's a little tidbit that's new. Absolute extrema is the absolute highest point there, or the absolute lowest point there. But what do you notice in this visual? It goes up forever. Is there a high point then that you can name? It goes down forever. Is there a solid point you can name for me for a low point? So there is not an absolute extrema. There's not an absolute max or min. However, I can talk about my relative extrema. How many of those can you count? 4. Good. So for relative, I count 4, because I can count 1, 2, 3, 4. For absolute, there are none. Question on that? Because you're going to be doing page 269 in a sec. Yes? Say it again. Infinity is not a point. Okay, the next one is a new concept. So I did not put it on Wednesday's test. However, it will be on future tests. You will see it all year. You will see it a lot in calc, so I'm getting you used to it. It is terminology you could see on standardized tests. So I want you to walk away from my course with, I know how to write all this stuff in all different ways, and I understand what the question is asking. State the intervals from something to something where the graph is increasing. Okay, so what I want you to do right quick on your graph that you have is I want you to go over the picture where you think it is increasing. Page 268, color over where you think it is increasing. Okay, so I highlighted for you where I think my graph is increasing. On the homework question, I think it talks about decreasing, so make sure you read the words. Now, I've already highlighted where the action was happening, where it is heading upward. Look up here, see if you have a question on that part.
How could the one all the way to the left be increasing?
Because you start from left to right, but that's a great question, from left to right. Anybody else? I don't mind. Okay, so now when I answer the question about the intervals, I'm talking about where it is on the x-axis. So from something to something, I can look at that picture and see where it's increasing. So 3 different intervals, it's increasing. So this is increasing from negative infinity, would you agree? To, because that's going to the left forever. And then at x is about negative 2.5-ish. It stops increasing. So if I were going to write myself a note, I might write from negative infinity to negative 2.5-ish. That's one of the places where it is increasing. Look at where I highlighted, look what I wrote. Brand new concept. Let me finish and I'm going to take all the questions. Okay, now, look at my second turquoise. I want x values only. I don't want you to tell me their heights. I want the x value. So turquoise starts at about -1. Would you agree? And turquoise ends at x is about 1/4 or 1/2. That's another interval where it's increasing. Third time. This looks like the turquoise starts at 2 and a little. And the arrow is not only going up, but isn't it going to the right forever? So where am I going to? Infinity. So when you write these intervals, you're writing them in terms of their x values for the action that it asked, in this case, the increasing. Now, question.
I don't understand why you wouldn't put the height, like if you're trying to get, so if you're going from like the lowest point, but you're not.
It's not asking for maxes and min values. That's what you'd be answering. The intervals are where it's happening. So like if I wanted to tell you, when I give you that interval, I'm telling you the part of the graph I want you to look at. So when I say from -1/2 to -2.5, then that would mean that you could ignore all that part of the graph. That's the interval I want you to look at. Or if I want you to look at from 2.2 to infinity, then I don't care about any of this right here. I don't even care about that. So that would be telling you, okay, that's the part of the interval I want you to look at, nothing else. See how it doesn't affect the y value? Anybody else? Clarification on that? So that's why I didn't put it on this test, but it will be in future because you do need to get used to it. Okay, so your homework, classwork, page 269, number 8. On page 275, it's done for you. Read it. Page 276, that's what you're filling in. Work on that study guide today after school, tomorrow in class, whatever you want to ask me from the study guide. Remember the test is Wednesday. Remember the survey is due tomorrow. So you've got all this upcoming. You know that tomorrow is Tacky Tuesday. For those of you that are dressing up, that's upcoming as well, okay? And then remember there's a difference between odd degree and odd function. Odd degree means the biggest exponent there, okay? The odd function is where you test for symmetric about the origin or the y-axis, okay? So use your time wisely, please, okay? Yes, it is.